Hello, Paul, Ram, Arun. I'm recording this video to talk about the work that I'm presenting that I'm sending via email. And I also want to send this video so that it's convenient and easy for you to look at this paper and give me some feedback. I'm talking about the effect of cleaner diesel fuel on health on this paper, which has the research question whether a city ordinance in 2005 in Quito to reduce the content of sulfur in diesel had positive health effects on the citizens of Quito. I'm going to go kind of quick. I want to keep this to under 15 minutes. Just a quick word on my notation. R1 in this document is going to stand for acute respiratory illness, R2 for chronic respiratory illness, and C1 for cardiovascular illness. I'm going to divide my analysis by different age groups, children under 6, adults over 65, and all ages. I'm going to look at Quito and I'm going to look at Cuenca, and my focus in graphs and regressions are going to be on rates. So that's going to be the total hospital admissions for unique sicknesses for each city divided by total admissions for all sicknesses. And I can do this by age category as well. Okay, jumping into subject matter here. The first thing I wanted to do was to see what was happening to air quality around the time of the policy. In these graphs and in most of the graphs that I'm going to be presenting, I have two vertical lines. The first one is at May 2005, and that's when the policy was signed and enacted. The second one is at April 2006, and this is when the policy was fully implemented. So that means that in April 2006, 100% of vehicle diesel was of the premium quality, premium being less than 500 parts per million. Okay, we see that there's a very clear drop in sulfur dioxide, in fine particulate matter, which is fitted here with a red polynomial fit, in nitrogen dioxide, and a strong decline in carbon monoxide, which is more associated to gasoline emissions, but it is part of diesel SUT as well. So these declines indicate to me that there are going to be declines in hospital admissions for these sicknesses, or that I should expect them at least. The strategy that I want to use is a difference in difference strategy, but before doing so, I ran some synthetic controls. And what I find from these synthetic controls is that consistently Cuenca is the city that is given the most unit weight. The one that I'm presenting here is just one version of many. I didn't include cantons or cities that were close to Quito because they could be affected by the policy and they wouldn't be good controls. And I see that Cuenca again showed up with the highest weight. So it makes me feel more comfortable with difference in difference strategy using Cuenca as my control variable. I still want to use the difference in difference strategy because from what I've seen in the literature of epidemiology, this is a more prevalent and well-established strategy. Okay, it's very important when doing diff and diff to look at pre-treatment trends and to see that there are common trends between the treatment and control groups. I do this by looking at admission rates. Admission rates for particular sicknesses divided by all sicknesses in each city. And I see that for acute respiratory illness, Quito and Cuenca are moving very similarly. It's not so clear for R2 and for C1 between Quito and Cuenca, even though it does seem that there are also similar patterns. There is also more volatility. I do the same analysis but looking at residuals. So I run a regression on only month fixed effects, and I look at the residuals of these regressions and I compare them to Quito and Cuenca. This is before the policy was enacted. And again, for R1, they're not always parallel, they're not perfectly parallel. And one of the questions I have for you for some feedback is whether these are good graphs to show. But it seems to me that they are giving further support to my case that there does seem to be somewhat of a similar trend here before the treatment. Here, for example, for cardiovascular disease, there's much more volatility in Cuenca relative to Quito in this deseasonalized graph, but the general trend seems to be the same for both cities. Moving on to post-treatment impacts, I look at post-treatment by looking at the difference in the ratios between cities, and I find that when I have a vertical line right at April 2006, again, this is when 100% of the policy was implemented in the city, so that all diesel was of the premium quality. There's a discontinuity that is very consistent with what I'm looking for in my hypothesis. That's for R1, R2, and C1 when comparing the ratios of Quito and Cuenca. I also did the same analysis, not comparing the rates, but comparing just the levels. And I found similar. R1 wasn't so good with the levels, C1 was much better. But overall, there seems to be an effect of the policy after April 2006. For the post-treatment impacts, I also look at the residuals, and we see that right around the time of the policy, actually even a little before, which isn't ideal, but right around this time, the trends of for Quito, which is the red line, and Cuenca begin separating noticeably. And this is for, again, for R1, acute respiratory illness. And this is for cardiovascular illness. The drop in Quito admissions for cardiovascular illness is dramatic here relative to Cuenca. But my results here for R2, which are chronic illnesses, aren't too encouraging because the separation isn't consistent. They come close together again around this point, and Cuenca is always below Quito. So that's also not what I'm hoping. So R2 not too good. R1 and C1 seem promising for my results. Okay, I want to quickly talk about my empirical model. I'm using a log linear Poisson difference in difference model. Even though I know for a fact that there's over dispersion in my data. Well, I didn't compare the conditional over dispersion, which is important, but I just looked at the simple variance and the mean, and there seems to be over dispersion, and there usually is in this type of data. I'm not using a negative binomial, and I'm not using this because I found a lot of literature saying that the negative binomial with fixed effects is not a real fixed effects model, and that it's much preferable to use a Poisson fixed effects model instead of a negative binomial, as long as I cluster my errors. So I'm doing that. I'm citing some literature that talks about this as well. My model is it's an offset model, so I'm looking at total hospital admissions per age group as an exposure proxy. So I'm looking at total hospital admissions as a proxy for population. Population being my exposure that I'm interested in. I've read a lot about this. I'm citing a book here that explains that this is very common in epidemiological studies. And it does warn, however, that I have to be very careful about doing this. So I do present, and I just don't have time to go over it right now, but I do present an analysis where I compare population figures to hospital admissions, and I compare Quito and Cuenca hospital admissions with a little bit to read about what I believe are the conclusions that I can take. Overall, I think I'm comfortable with this strategy, and I think that my offset of total hospital admissions is going to do a good job. I also have some examples of other literature that has done the same. Okay, my econometric model, the regressions that I'm running are a log linear model. It's the log of the specific sickness per age group in a canton, year, and these are monthly averages. So we're talking about hospital admissions again. It's the log of the hospital admissions for a specific sickness. And this is my offset. So these are all sicknesses for the same age group in the same canton, year, and month. And beta 3 is my difference in difference estimator. Q is 1 if in Quito, and April 06 is 1 if after April 2006, which is when the policy was fully implemented. I'm also including year-month fixed effects, which are going to be common to Quito and Cuenca. And to give a little bit more flexibility to the seasonal differences that exist between these cities, I'm including a month-city interaction effect for Quito. So the reason I'm doing this is because I know, and I have presented before, and I'm sending you this as well, that the weather patterns, even though they're around the same temperature, Cuenca is a little bit colder than Quito, but the weather patterns are different. The time of the year that is coldest in Quito is not the time of the year that is coldest in Cuenca. Well, Cuenca and Quito. So because of this, I think interaction enriches my model, and it's going to capture these differences. Furthermore, I'm clustering my error at the city and at the city year level, and I'm also calculating robust standard errors. Okay, this is just what I've talked about, the samples and the sicknesses that I'm looking at. I've tried many things. I've tried looking at temperature controls. They didn't add much to my model. I looked at I separated regressions by different seasons in Quito, and that's basically looking at a difference in difference in difference regression, but these didn't turn out to be significant. And I also ran some event study models, which had a mixture of results. They weren't consistent. Some of them looked the way I wanted them to look. The relative coefficients drop around the time the policy is implemented. But they weren't, I didn't find consistent results in this. And I think one of the reasons is, and maybe this takes away from the merit of an event study model, is that the policy actually was implemented much more immediately than what at first I believed. I believed that it was spaced out through several years, but it took 1 year for it to be fully implemented in the city of Quito. So a strict difference in difference cutoff around that year seems to be a better strategy. Okay, quickly looking at my results. Overall, I think they're pretty encouraging. When I look at the results for R1, again, acute respiratory illnesses, I see that all of my coefficients are statistically significant. And they're pointing to a relative decline in the difference between Quito, in the difference in the rates between Quito and Cuenca. As a matter of fact, this is the coefficient, the way to interpret the coefficient. I added this on here. If we just look at the coefficients themselves, what they are is they're essentially the log of, this should be expected value, as a matter of fact, the log of the expected differences after the policy divided by the expected differences before the policy. And the difference is, the log of this is negative. If I take the exponential of this coefficient, I'm just going to have the ratio of the relative differences. And this turns out to be, for example, for this one, the ratio is about 0.98. So that's telling me that the difference between Quito and Cuenca after the policy was 98% of the difference between the two cities before the policy. So there was approximately a 2% drop in the relative hospital admission rates in Quito relative to Cuenca. Okay, that's the interpretation of these coefficients, and there seems to be an effect for acute respiratory illness. I can't say the same for chronic respiratory illness, and this is kind of consistent with what I found in my residual analysis, that I wasn't going to find good results here, and I don't. They're not statistically significant. The one that seems to be somewhat different than zero is positive, which is not what I want either. So that was kind of expected. And for cardiovascular illnesses, I have very strong effects. And here I want to point something out that I'm forgetting to point out, and I have about a minute to do so. And that's that I ran this regression on two different concepts of what Quito means. One is a wider concept, which includes the outer parts of the city, which are more rural and agricultural. And one is just the urban center of Quito. What was surprising to me at first is that for all my results that are statistically significant, the results were stronger for the broader concept of Quito. And I think this could be because there's a lot of commuting going on into the city, and also because when you go out of the city, a lot of these people are living close to the roads anyway, so they might be affected by the policy. Okay, and this is just a map of what I'm talking about the differences in Quito urban center and the more rural areas of the city. Okay, so those are my results, and I hope you get a chance to look at this and give me some feedback about what you think of this work. Thank you very much.